Okay, this lecture is going to show you how to navigate through your data sets for the final project. For the final project, you're going to have a chi-squared goodness of fit, and then you're also going to have a chi-squared test for independence. And make sure that you pay attention to what it is that you're required to do with those. You may or may not be required to do one or both of those. So, right here we have this is an example of different company sizes, right? So I have all of these different sizes of these companies. This is the original data set. And I have all of these sizes of the companies, and I have the number of job openings that go right along with the size of the company. And so, depending on where they are, so Philadelphia has a certain number of openings for certain sizes of companies, and so does Los Angeles, so does Houston, so does Chicago, and so all of these different companies have different numbers of openings for different sizes, right? And so this right here is uh, specifically for San Francisco. So for San Francisco, for company sizes 1,001 to 5,000, there are 20,955 job openings. From San Francisco, from 201, these are a little out of order, but you'll notice on the right hand side it says here's the number of openings, here's the size of the company. And the question is with depending on how large the company size is, how does that relate to how many job openings there are? More specifically, is there a difference in the number of job openings based on the size of the company? And so, in order to test that, I'm going to assume that all of the job openings for the different company sizes are going to be the exact same. So I'm assuming that these are the exact same because I'm going to test if they are different. So that is what a chi-squared goodness of fit test does, is are they the same? And make sure that you read your yellow box to really understand what your data does. So right here we have our questions, right? We have what is a test statistic? Right now we're doing chi-squared, so I just copied and pasted this right here, chi-squared. Declared alpha level. This is completely up to you. What do you want your alpha level to be? To be completely honest, 0.05 would probably be fine. I would suggest either 0.05 or 0.1. And remember that alpha is that delineating point. It's saying, do you want to be 99% confident or 95% confident in order for you to be able to say that there is a difference? And so for us, we want to be 99% confident to say that there's a difference. Next question, how many categories do you have? Come right over here and you'll see, okay, we've got 1, 2, 3, 4, 5, 6 categories. Only 6 categories. I don't know why it says 8, but we've got 6 categories. And the degrees of freedom is going to be 5. And the next question, because the degrees of freedom, let me explain that. The degrees of freedom is going to be the number of categories minus 1. The number of categories minus 1. Okay, and so now we've got a total of 6 categories, 5 degrees of freedom. Make sure that your information right here is correct, because this is how I'm going to check your answers. If your information in here is not correct, then all of your answers below are going to be wrong. So what is the chi-squared calculated value? Let's see here. Hold on. The degrees of freedom, equal or unequal proportions. We are going to set it up for equal proportions because we're going to see, is there a difference? And then the total number of observations. In order to see the total number of observations, we look right down here at the bottom, and we're going to see 13,700 and 137,899. So come right over here. Once again, I don't know why that's wrong, but I'm going to change that. And then the chi-squared calculated value, we'll get into that in a minute. And so, yeah. Let's, what we're going to do now is we're about to take this data right here, okay, and we are about to put it into a different location. So I want you to copy this information from yours, and I want you to scroll over to the right hand side, and you'll notice you can just copy and paste. Whoops. Let's see here. What did I do here? Yeah. I copied a little too much. Control C, and then Control V, and then press paste. Now, in your previous exercises, I actually had you calculate all of this information by hand, but this time I actually have a calculator just all set up for you to do it for up to 12 categories. And so I would encourage you just copy and paste it into here. I've already done all the calculations, and hopefully what this is going to do for you is it's just going to make it a lot easier for you to be able to look at it and be like, okay, I don't have to do all the tedious calculations. All that I have to do is interpret it. Another thing is, you notice how these aren't in order? I would really love for these to be in order. Okay, and so this is what I'm going to do. Don't ever cut. When you're dealing with this, don't ever cut, only ever copy. Okay, so make sure that you copy and that you don't cut. If you cut, it'll mess up all these formulas in here. So you can press Control C, Control V, Control C, Control V, and you notice it updates everything. And so I'm just putting these in order, and so I'm Control C, Control V. Let's see here, up to 1,000. Where's the one that goes up to, oh, yep, 500. And then, oops, don't forget that. And then up to 200, right there, Control C. And then last but not least, less than 50. So now I've got these all in order, and I'm going to press Control C, put them at the top, and then I'm going to delete everything at the bottom. And so it worked out just fine. So just be very careful that you don't cut. Only copy and paste. When you cut, it messes up the formulas. So now you've got this right here, then you've also got the p-value, you've got the chi-squared value, the degrees of freedom, everything is calculated right there for you. You even have the percent of chi-squared. So I did that to try to make your lives a little bit easier with that. So chi-squared calc, I'm going to press Control V, and so that's chi-squared calc, and then the p-value is 0. The probability of this happening, assuming that they are equal, is 0. In other words, they're definitely not, they're definitely not, the result is definitely not very probable. Let's see if I can make this, yeah, I don't even know how many zeros there would be. So I tried to find the probability, the actual probability, but it's just very low. And when you have a probability like this, instead of saying 0, it's actually a lot better to put Control C. Probability is less than 0.000001. In other words, I mean, obviously, this is probable. It's just the probability of it is so low that it more or less might as well be 0. So, here is the research question. The research question is the proportion of job openings in San Francisco equally distributed by company size? And the really easy way to just get the verbiage the way that it needs to be said is by going to the goodness of fit reference down here. And you'll notice, okay, so what are the different purposes? And when you have the different purposes, you actually have the ability to, change those purposes into a research question. So to determine if the observed frequencies are equally proportionate between categories or groups, I basically took that and I brought it back to the chi-squared goodness of fit, and I said, what's the research question? Are the proportion of job openings in San Francisco equally distributed by company size? Okay, so what's the purpose of running this test? Same thing as the research question, but more just a statement to determine if the observed frequencies of job openings in San Francisco are equally proportionate based on company size. And let's see here, we can, wrap text. We'll make that a little bit, there we go. between company size. And then what do we expect to happen? It's anticipated that the job openings will not be proportional between company size. So in other words, we expect that that some companies sizes will have more job openings while other company sizes have less job openings. So next question, what is the one categorical variable, which is right over here, company size. This is the categorical variable, company size. And notice that this is quantitative, right? This is quantitative, discrete, but discrete quantitative data. And then we broke it up into categories. And so it became a categorical variable when we broke it up into categories. Okay, so the categories are 1001 to 5000 to and so on and so forth. And so we've got those different categories. Next, assumption 2, describe how you know that the observations within each group are independent of each other. So job openings fall into one of these groups and cannot be in more than one group. And then next, ensure that the expected frequency is at least 5 for each group. And so just come over here and say, okay, what is the expected frequency? We haven't talked about this yet. So the expected frequency is essentially this total number divided by the number of categories. So I have this fun little formula in here, and the expected frequency is equals this divided by how many categories? Count A, and then there we go. So basically what I just did is I did a count function right there. So count A, and then let's just put a fun little $sign and a $sign right there. And we'll put $sign right there too. And just drag it down. And now the expected is going to be 22,983.1667, and if you add all those up, it equals 137, which is the same as that. Okay, so that is the expected. So we can say that the minimum expected frequency is 22,983. Let's just make sure that that's right. 22,983.17. And then are the frequencies between each group expected to be equal or proportionate or something else? The proportion is being tested against being equally proportionate between company sizes. That's what we're doing. So what is the null and alternative hypothesis? Once again, I have all these things written out. Really simple. You come right over here, and for the goodness of fit, just copy and paste this. Copy, Control C. Go back to the goodness of fit. And you can paste it and just, whoops. You can paste it and modify it, okay? So if I were to paste it right here, you'll see there's no difference in the proportion of groups. There's no difference in the proportion of job openings in San Francisco based on company size. There's no difference in, there is a difference in the proportion of groups. And so there is a difference in the proportion of job openings based on company size. So basically, I already have it there for you. Just modify it for your use. The next thing that we need to do is calculate the critical value. Once again, there's two ways to calculate the critical value, and I'm going to show you the first way is using an Excel formula, and I'm going to use this Excel formula. I'm going to do equals chi-square dot inverse dot right tail. So this tells me the probability of a right tail test with a particular value for chi-squared. And so we are going to put 0.01 is the probability, which is the alpha level, and then the degrees of freedom is 5, right? So we're going to put 15.086. This right here is very accurate, much more accurate than using the but if you want to use the chart, this right here is the chi-squared chart. You've got the 0.01, and then you've got the degrees of freedom. So degrees of freedom is 5.01, and the intersection of those two is going to give you 15.09. So you've got 15.09 using the chart or 15.086 using this formula. It's going to be the same exact thing. Okay. Next, we've got the test calculated value. We already determined the test calculated value right here. So you just have to copy it from right here, paste it into right there, and this is the chi-squared test calculated value. And then the p-value, we already determined the p-value is right below that. And the way that you determine the p-value is equals chi-squared distribution right table. In other words, or right tail, you're finding the probability of you having the particular chi-squared value. So I'm going to put the chi-squared value right there with the degrees of freedom, and that gives us 0. So the probability of this is 0. Next, statistical significance. You compare the p-value to the alpha. Okay, so the p-value of 0 compared to the alpha, we know that this is statistically significant. The probability of this result, assuming the null hypothesis is true, is virtually 0. And notice I didn't say 0, I said virtually 0. As the p-value of less than 0.00001 is less than the alpha value, the results are statistically significant. You can literally copy this and paste it and just modify the words. Okay? Next, as the make the hypothesis decision, as the chi-squared calc of 47,263.538 is greater than, it really should say chi-squared crit, then chi-squared crit of 15.086, the decision is to reject the null hypothesis. And then chi-squared calc of 47,000, interpreting chi-squared, we say chi-squared calc of 47,263 indicates that there is a difference between the proportion of job openings based on company size. Chi-squared is, in and of itself, is kind of a useless metric. Okay? All that it says is there's a difference somewhere. There's a difference somewhere. But what is that difference? And that's why this step right here is, in my opinion, one of the most important steps, and barely anyone does it, and it drives me nuts. So make sure that you do it, and make sure that you do it well. Okay, so interpret the chi-squared, the percent chi-squared. In the far right-hand column, we have the percent chi-squared. So you've got this right here and this right here. Anything, you want to interpret anything that is above 10%. If it's below 10%, I don't care. But if it's above 10%, just highlight that in yellow. And then what I want you to do is look at the difference score. This right here is the difference score. This difference score, I'm going to have you highlight in red. And this difference score, I'm going to have you highlight in green. And the reason why I'm having you do that is because when you have it highlighted in green, that means that it is above what's expected. When you have it highlighted in red, it means it's below what's expected. And so what we see here is that there are two major discrepancies. There are two categories that contribute the most to them not being the same. And the other three are pretty close to what they're expected to be. So company sizes that are between 501 and 1,000 are 15,981 job openings below what's expected. Or to put this into a different perspective, so equals, let's see here, ABS divided by, we are essentially 70% below what's expected, okay? 70% below what's expected right here. And then this one right here, let's see here. Okay, so what we're going to do is equals this, the difference score divided by the expected score. This is 119% above what was expected. This is 70% below what was expected. And so that's a really big deal. And that's what we need to be reporting. So I'm going to copy and paste this, Control C. I'm going to come over here. And I am going to look at the, interpret the chi-squared. And I'm just going to paste that right there for a second. paste the values. Okay. By interpreting the percent chi-squared, 69% of the contribution is attributed to the difference in job proportion openings based on company size. That is attributed to companies larger than 50,000 employees. There are more than 27,000 job openings more than the frequency, which would indicate a uniform distribution. And you can say this is 119% more than what is expected. Second, companies between 501 and 1,000 employees contribute 24% to the chi-squared value, with only 7,002 openings. This is 16,000 openings less than the expected 22,983, which is about 69.5% less than what is expected. So this really demonstrates where is the difference coming from? Where is the difference coming from? And so the percent chi-squared is really, in my opinion, the most important aspect when interpreting this. Next, we want to interpret the effect size. We've got the effect size here, and I'm going to show you guys how to do this really quick. So V, the way that you calculate Kramer's V is by first putting in the chi-squared value. So I'm going to do equals the chi-squared value right there. Then I'm going to do the total number of observations. So equals the total number of observations. And then I'm going to put the degrees of freedom equals the degrees of freedom. And then V. So I have it set up to be set up just like that. And in that formula. So you've got the chi-squared, the total number of observations, and the degrees of freedom. And in order to calculate it, just follow this formula right here. So we're going to do equals square root, because it's all in the square root. And then I'm going to do another parentheses, put chi-squared divided by parentheses n multiplied by the degrees of freedom, and that will give you a Kramer's V of 0.2618. So I'm going to copy this and bring it on over here and put it in right here. So the effect size is 2.618. And if you recall in the videos earlier, I teach you specifically how to determine whether or not it's a small, medium, or large effect size. And so the really easy way to do this is, let's put the 0.1, 0.3, 0.5. Better yet, let's do this. Control C, Control V. Then we will have small, medium, large. And then we will have degrees of freedom equals degrees of freedom, and so it's going to be equals this divided by the square root of the degrees of freedom, which will tell us whether or not we have a small, medium, or large effect size. Okay, so we have for a small effect size, it should be 0.44 or smaller, which I once again messed something up. Hold on. We need to have, there we go, 0.447 or smaller. For a medium effect size, it's going to be somewhere between, somewhere right around 0.134. And for a large effect size, it's going to be 0.223 or higher. And so you'll notice this 0.2618 is a large effect size. And this will work with anything. So if you have 126, if you have all those degrees of freedom, you'll be able to see that the small, medium, and large effect size threshold changes. So for 5, this is the threshold, and so it's a large effect size because it's above that large threshold. And so the Kramer's V effect size is a 0.268, is a large effect size, and you can put compared to the large effect threshold of and I think I said 0.226. What is that? Yeah, 0.2236 of 0.2236. These results are noticeable even without a large sample size. And if you don't want to use the formula, you can come over here and you'll notice, okay, 5, you come all the way over here and you'll see, oh, yeah, there you go. There's, it's already in a table, which the table's great. Or you can just use this formula right here and you don't even have to worry about a table. Can you tell that I'm not the biggest fan of tables? And so sometimes I prefer to just get rid of it. Okay, so we determined the Kramer's effect size, and now we're going on to our discussion. Write a discussion of the results, providing an appropriate inferences and and insight in a way an 8th grader could understand it. Okay, so what you're doing is literally just following this all the way down. Okay, and I'm just going to be checking, did you do this, did you do this, did you do this, and, is it correct? So first of all, what was run? A chi-squared goodness of fit test was run. Okay, what was it comparing? It was comparing the frequencies between job openings by company size to determine if the openings between company size, openings by company size in the city of San Francisco are the same. Okay, and notice I'm writing this in a fun paragraph way, but I'm putting it each one on a new line just to make it really easy for me to see, okay, this is what you did, this is what you did. Okay, so what was the result? The chi-squared result of 47,263 indicated that there is a difference. That's all that it does. Indicates that there's a difference between the proportions of job openings by company size. Period. Okay. The probability of this occurring randomly is almost non-existent, so this is the p-value, is almost non-existent, indicating that the results are very trustworthy. In other words, if the probability of it occurring is almost non-existent, it means that the probability of type 1 error is almost nil. The probability of saying that there's a difference, but there really isn't a difference, is almost completely gone. Next, by interpreting the percent of contribution of each category of corporation size to the chi-squared score, and I literally, what I did here is I just copied and pasted directly from here into here. Because I already wrote it really well up here, so there's no point in rewriting it. So a lot of what you're doing is, just taking what you did up here and rewording it in such a way that it's really easy to understand down here. This is 119% more than what was expected, and then these results are very noticeable. This right here is mention how noticeable the results are. Where does this come from? This comes from the effect size. Effect size. Effect size tells us how noticeable these results are, how practically significant they are. They're very noticeable even with a smaller sample size. However, with the larger sample size, we not only notice the results, but are able to establish the extremely low probability of this occurring, assuming that the number of job openings are the same by each company. So in other words, because we have such a large sample size, we can see that there's a big effect size, but we can also see that the probability of being wrong is very small. Lastly, should I use this information? And this is really important because all the time we use information that we really shouldn't be using. Like for instance, if you have a p-value of 0.9 or if you have a p-value, a probability of getting this result of 0.09, that means that you've got almost a 10% chance of being wrong. So in this case, the effect size is very large, it's very noticeable, and the probability of being wrong is very small. So therefore, these results should definitely be used to provide insight for those who can benefit from this information, because the probability of saying there is a difference when there really isn't is very small, and the results are very are practically significant and noticeable. Okay, and so that's kind of how you write that up. I'd suggest, just follow along with exactly what it says on the left-hand side and just answer each one of those questions one after the other, and you'll be set to go. And that's pretty much it. Let's see here. Oh, there is one more thing that I want you to do. The one more thing that I want you to do is I want you to go like this, insert, and we're going to insert, let's see here, we're going to insert this. These are bar charts. Whoops. I want you to highlight the observed frequency and the expected frequency, and I want you to do insert bar chart. And there's a couple different bar charts that you can do. Like this one right here is not appropriate. So the stacked bar chart is not appropriate. This one is appropriate because, well, no, not really. The only one that's actually truly appropriate is probably this one. And the reason why is because it shows you the expected frequencies right next to the actual frequencies. If you do this one, it adds up the expected frequency to the observed frequency, and this one right here, what it does is it says basically gives you a proportion of how much is the expected frequency compared to the actual frequency, where this one is almost 50-50, and it kind of shows you which one is greater, which one's smaller, where this one's greater and this one's the smallest. It shows you proportion. As long as you understand what it is, it's a good chart, but it's just not what it is that we're looking for. So we're going to change this chart type, and let's see here. Like, you could do that, or you could do this. I like this just because it's clean and it's simple, and so we're going to stick with that. Expected frequency, observed frequency, and then what we need to do is comparison of job openings based on company size. Okay, and then press X, and you're going to bring it right down here, and then press V, and now we've got that wonderful chart. Make sure that you put the chart in there so that way you can get the full credit for that. Okay, other than that, I think that's pretty much it. Let's see here. When should I... Yeah, no, that sounds good.